Okay, in this chapter, we'll start the chapter that is 13.3 topic, that is force on a current carrying conductor in a magnetic field. So here, first one, that is previously we discussed about the electric current, okay, flowing through any conductor and it produces the magnetic field. Okay, if we take the any conductor is copper rod or aluminum rod and pass the electric current, so it produces the magnetic field around it. So that is 17th century, that is between 17th and 18th century, that is French scientist Andre Ampere, okay, and he was suggested that the magnet also exert equal and opposite force on a current, okay, carrying the conductor, and this experiment demonstrated by the Andre Ampere. So for that he take the small rod, that is AB rod, okay, that is aluminum rod you should be take, that is AB approximately 5 centimeter length, and suspended it on a stand as shown in figure. Both the ends A ends and B ends are connected with the simple battery and simple key as shown in figure. Okay, so first you take the stand, take the aluminum rod approximately 5 centimeter length. Let tell it is AB length. Okay. AB length is 5 centimeter. Now both the ends of this aluminum rod connected with the battery and simple key with the connecting wire. Okay, as shown in figure. Now you take the horseshoe magnet. Okay, you take the horseshoe magnet, okay, as shown in figure. So this horseshoe magnet, you have to place strong horseshoe magnet in such a way that the rod lies between the two poles, okay, with the magnetic field. Now north pole of the magnet vertically below and the south pole vertically above the aluminum rod, okay, that is N and S direction. So observe that. Now you have to press the key as shown figure. Okay, switch is on, key is on, so current will be flow from positive terminal to negative terminal, that is from B to A side, positive terminal to negative terminal. So you have to be observed that rod is displaced towards the left side. Okay, rod is displaced towards the left side. You observe that is a blue arrow. Okay, you have to observe that blue arrow. So rod is displaced towards the left side. So here, if you change the polarity of battery, okay, polarity of battery will be changed from positive to negative and negative to positive direction, and current will be passed. So at that time, the displacement of this rod, it is in opposite direction, that is in right direction. Okay, so reverse the direction of the current, that is change in polarity of the battery, the current will flow, that is in a opposite direction, so displacement is also in opposite direction. So here the displacement of the rod in this activity suggests that the force is exerted. Which force? Magnetic force is exerted, okay, on the current. So when it is placed in a magnetic field, when it is placed in a magnetic field, it also, that is the direction of force is also reverse, because the current will be changed. Okay, direction will be changed, the magnetic force is also in reverse direction. Okay, so from this activity, that is we conclude that magnetic force is directly proportional to direction of electric current, direction of electric current, because it is placed in both the side. When we change the polarity of the battery, it will be displaced in opposite direction. So it means that the magnetic force is directly proportional to the direction of electric current, and as well as magnetic force directly proportional to the direction of magnetic field. Okay, so it means that magnetic force directly proportional to direction of electric current and direction of magnetic field. Now here, if we know the direction of magnetic force, okay, if we know the direction of magnetic force, so we can be understood from the Fleming's left hand rule. Fleming's left hand rule. So here we observe that is Fleming's left hand rule. You can study here. So we have to arrange the left hand, okay, such that the forefinger, the center finger, and the thumb remain at the right angle. Okay, કરી જુઓ બધા જે hands છે ને એ પોઝિશનમાં લેફ્ટ હેન્ડ લો and observe their figure very carefully. You have to arrange the left hand in such a way that the forefinger, હે હેલો, લેફ્ટ હેન્ડ છે બકા, લેફ્ટ હેન્ડ લેવાનો છે તમારે, લેફ્ટ હેન્ડ, ઓકે, લેફ્ટ હેન્ડ એ રીતે અરેન્જ કરો તમે જે એઝ શોન ઇન ફિગર. સો arrange the left hand in such a way that the forefinger, that is the middle છે ને થંબની બાજુમાં, it is a forefinger, okay, and the center finger, okay, third one is the center finger, and thumb remain at the right angle, okay, remain at the right angle. કર્યું બધાએ? Now arrange the forefinger pointing in the direction of magnetic field, okay, arrange the forefinger pointing in the direction of magnetic field and the center finger in the direction of an electric current, while thumb, direction of thumb gives the direction of magnetic force, okay. So here you can be observed that the magnetic force, that is thumb direction, is a magnetic force, okay, thumb direction, that is a magnetic force, and forefinger direction, that is it shows the magnetic field, while center finger direction, it shows the electric current direction, okay. So with the help of Fleming's left hand rule, we know the direction of electric current, we know the direction of magnetic field, and we know the direction of magnetic force with the help of Fleming's left hand rule, okay. So again I repeat this, you have to arrange the left hand in such a way that the forefinger, center finger, and the thumb, okay, remains at the right angle to one another. Arrange the forefinger pointing in the direction of the magnetic field and the center finger in the direction of an electric current, and the direction of thumb gives the direction of magnetic force, okay, that is EMF. You write EMF. E means electric current, M means magnetic field, and F means magnetic force. EMF, okay, electric current, the thumb gives the direction magnetic force, forefinger give the direction magnetic field, and center finger give the direction of electric current, okay. So that is EMF. E means electric current, M means magnetic field, and F means force, magnetic force, EMF. So here now decide the direction of magnetic force acting on wire with the help of this experiment, okay, with help of Fleming's left hand rule. Now ખબર પડી ગઈ બકા એક્સપેરિમેન્ટમાં, એક્ટિવિટી 13.7 માં કે થોડી થોડી? Can you understand this figure or not? Okay, okay, very good. So here I repeat again, there is one time, that is a force on a current carrying conductor in a magnetic field. So here as shown in figure, that is we take the small aluminum rod, let tell it that is AB, and length of this aluminum rod is 5 centimeter. Now both the ends of this rod connected with the conducting wire, okay, connecting with a battery as well as simple key as shown in figure, okay, on a stand. Now you take the horseshoe magnet, okay, strong horseshoe magnet, and switch the current, that is switch is on, key is on, so current will be flow from positive terminal to negative terminal. Now with the strong horseshoe magnet, you have to be arrange that The rod lies between the two poles. Okay, whole rod, aluminum rod lies in the between the two poles. North pole of the magnet vertically downward direction and the south pole vertically above the aluminum rod. Now, so what you have to observe that when the current is flowing, okay, so rod is displaced towards the left side. The rod is displaced towards the left side. Now, next step, what you do, you have to change the polarity of the battery. Okay, positive, negative terminal, negative to positive terminal. So there will be, due to this, the direction of the current will be changed. So reverse the direction of the current, that is change the polarity of the battery, the current flowing through the rod, and observe the direction of the displacement. It means that it is in opposite direction, that is in now in right direction. Okay, it will be moves in right direction. So here the displacement of the rod, it suggests that magnetic force is exerted on the current carrying aluminum rod. Okay, when it is displaced in the magnetic field. So magnetic force is directly proportional to the direction of electric current as well as direction of magnetic field. Also it depends on the length of the strip, length of the rod. Okay. Magnetic force is also depends on the length of the rod, that is aluminum rod or copper rod. Okay. So here, that is if we know the direction of this magnetic field and electric current, so we treat the Fleming's left hand rule now. So in Fleming's left hand rule, that is we have to arrange the left hand, okay, in such a way that the four fingers, center finger, and the thumb remain at right angle to one another. Okay. Now you have to arrange the four finger pointing in the direction of the magnetic field and the center finger in the direction of electric current, and direction of the thumb gives the direction of magnetic force. So we can say that here the thumb direction, okay, it gives the magnetic force, forefinger gives the direction of magnetic field, while center finger it gives the direction of electric current. That is, remind that EMF. E means electric current, M means magnetic field, and F means magnetic force, EMF. Okay. So with the help of this Fleming left hand rule, we know the direction of magnetic force acting on a wire. Okay, with the help of this experiment. Now, see that there is in text question there. One, that is which of the following property of a proton can change while it moves freely in a magnetic field? Okay, there may be more than one correct answer. So here, which of the following property of proton can change while it moves freely in magnetic field? So as we know that the momentum P is equal to mv. Okay, in ninth standard we have to discuss about the momentum. Okay, law of conservation of the energy P